up guys, welcome to the 10th tutorial in our Python language basics. Here we're going to cover the topic of multi-dimensional lists. This is a direct follow-up to just regular lists, and we have a fairly short one ahead. So we'll just talk about creating two-dimensional lists, or matrices as they're often referred to, and then how to access and modify the entire lists within lists, or just individual elements. So let's head on over to the code. Now the first thing we want to do is get ourselves a cell started up. I am assuming that you are comfortable with lists from the previous section. If not, then make sure you are moving forwards because it's about to get a little bit weirder. Now the very first thing we need to understand is that multidimensional lists are really just lists. Okay, we can treat them as regular lists, but instead of each individual element being just a single value, it itself is a list. Okay? So any list functionality still applies to the overall list. It actually even applies to the inner elements, which are lists themselves, just not to the inner values within them. And also, we don't necessarily have to stop at two levels. We can have lists of lists of lists. So each of the elements of the inner list can themselves be lists, but we'll stick to 2 dimensions for now. Okay, so the first example that comes to mind when thinking of multidimensional lists in a game development portion, game development sense would be to think about a universe structure. So if we're building an entire universe with multiple worlds, each of those worlds have multiple levels, we might want to set those levels up in a multidimensional array. So think about something like Super Mario where you have multiple worlds that you're traveling between, and then each of those worlds has several levels within it. So we'll just represent these levels as numbers. Okay, so we'll call this something like universe is going to be equal to this. We have the outer list, like so. And instead of each individual element being, let's say, like a 1, 2, or 3, each one is going to be a list itself. Okay, so I'm just going to put 4 down, just to kind of mix things up, so we've been working with 3 a lot. Okay, and then within each of these inner lists, I'm going to put some values. So I'm just going to do 1, 2, 3. Maybe we have 3 in the first world. In the second world, we have maybe 4. Okay, third world, maybe we just have 2. And then the fourth world, back to 3 elements, maybe. Okay, so we can lay things out like this if we want. I actually find this a bit harder to read. So what I'm going to do is to shove these onto new lines. And I think especially starting out, if this is your first time with multidimensional lists, you should really structure things this way. I think it personally makes things a lot easier to see because now we can kind of understand the 2-dimensional structure of it. We can very clearly see the rows and the individual columns. Okay, now this is one big caveat to 2-dimensional array, 2-dimensional lists, is that they don't all have to be of the same length. Okay, we have 3 elements here, we have 4 here, 2, and then back to 3, and that will happen a lot. Okay, so that means there's an extra level of checking that we have to perform. We not only have to check the length of the entire outer list, so that would be 4, but we also have to check the lengths of the inner lists. Okay, before we only had to work with 1 dimension when accessing elements, so we'd only had 1 index to deal with. Well, now we have 2 because we have to specify the row that we want as well as the column. However, that's pretty easy to do. In our case, we know exactly what the structure is, so that's fine. We know if we want this one, we know it's at row 0, 1, and 2, okay? And we know it's at column 0 and 1. In fact, let's go ahead and fetch that. So let's say we want this world. It is the 1, 2, 3, 4, 5, 6, 7, 8, 9th world, so let's call it that. And this is going to be our universe. We're going to first get the row, okay? So in this case, 0, 1, 2, it's row 2, and then beside it we now need the column, so in this case 0 and 1. Okay, and let's just go ahead and print out 9th world if we really want. Okay, so let's go ahead and run that, and we get 2. So that's exactly what we would expect because we're accessing the second or the index of 2 for the row there, and then the column of 1. Okay, obviously this wouldn't work if we tried to access the second column because this doesn't exist. So that's why, again, you'd maybe want to perform an extra level of checks. Now, modification works in exactly the same way. I could change up this if I wanted to. One thing actually I didn't mention in the previous section, which perhaps I should have done, is that if I change 9th world, this has no reference to universe. Okay, so if I change up this variable called ninth world, then universe won't change. So if I say something like ninth world is equal to 5, okay, and then I print out universe, all right, you'll see that it hasn't changed at all. So this was basically copied into ninth world. We reassigned it, but universe doesn't change. And that's because we are copying the value. So when we do something like this, we're actually just copying this value that we find into this variable. Okay, if we change this variable here, it holds no reference to here, so this is unchanged. Okay, so that's something very important to note. This might change when it comes to using objects and classes, but more on that much later. Okay, so if we wanted to change an element, we can absolutely do so. Again, just access the row and column. Also, these are just regular lists, okay? Just as this outer list is still just a regular list. So we can absolutely add items to it. For example, let's say I want to add something to my universe. I want to add in a whole new world, okay? And no Aladdin references there, please. We're going to take the universe and we're just going to append a new list to it. Maybe I have 1, 2, 3, 4, and 5. Okay, and then if I want to print out my entire universe, I totally can. You can see that we have the other item, the new world, added to it. Okay, if I wanted to maybe add in a level to this guy, then I can. In that case, I would do this. I would say universe of see, we want row 0 and 1, okay, and in that case I'm accessing this whole list. Okay, so universe of 1 is this whole list rather than just an individual element. So in this case I want to maybe, actually, you know what, maybe I'm going to remove this item, so I'm actually going to do universe.pop. So I only want 3 levels in this particular world. Then I'll go ahead and print my universe again, and you can see that this second world has been reduced to only 3 elements. All right. So that's pretty much all I wanted to cover. I know multidimensional lists, as soon as you hear the word multidimensional or matrix, things start to seem kind of scarier than they actually are. Really, they're just lists of lists. We can treat those lists as individual values, and well, that's kind of it. Like, each of the elements is just a list rather than a single value. Otherwise, the same functionality really applies to the outer list as to the inner lists, okay? We just have to perform one extra level of checking if we don't know the length of each of these, and then we need to make sure that we're accessing row, then column, and not the other way around. Okay, so that's it for now. This is definitely something that I recommend you practice until you've really got the hang of it. You understand this row column structure. Again, you can have any type of variable you want in there. We just happen to use integers here. When we come back, we'll be exploring the next collection type, which will be tuples. So stay tuned for that. Thanks for watching. See you guys in the next one.